Good morning. This is CS 205 on February 13th. That's a Tuesday, and it's a snow day at Mass Bay. So I'm recording these notes as what we would have covered if we had had class. And so I expect everyone to listen to these notes and be prepared for Thursday. And here's where we are on the syllabus. We're in our fourth week of class that began on Monday, February 12th. The first week, we studied algorithms with Guido and Python. And then the last 2 weeks, we've studied logic proper, the logic of propositions, and then consistency and paradoxes, and looked at various applications, various problems. And this week, we start patterns of deduction. So the focus or topic changes from individual propositions and their relationships, which is the study of logic, to arguments. And it's in chapter 3. And while we don't have anything scheduled this weekend, I believe that you likely will want a second attempt at concept check 1. So this weekend, there'll be a second attempt at concept check 1, especially because on Monday, there's no class. Although we don't have class on Monday, there won't be any classes at Mass Bay, so that we'll have a long weekend in order to complete the second version of concept check 1. Okay, well now that we've got the mechanics out of the way, let me point out that we're going to be looking today at the second and maybe the third of these 3 packet logic sort of packets. One is inference and one is proof patterns. So you should download those and have them handy when you're listening to these videos. And what I'm going to do is I'm going to try to divide it up into smaller segments, like 15-minute segments, so that you can sort of jump in and jump out easily without having to listen to a really long stretch of video without knowing where you are. Okay, so that's where we are. And we can take up questions on concept checks either now or in the on Thursday that you just finished. But let's start now with deductive reasoning. Now, the topic here is an argument, or the focus is on what's called an argument. Or which is the same thing, a proof. Because by argument, we mean a precise precise sequence of propositions that show that some result is true. So an argument or proposition has premises. And a conclusion. Okay, the idea here is that it's a valid argument is a sort of a list of premises and a conclusion each premise is a proposition. The list of premises and a conclusion in which the truth of all the premises guarantees um, the truth of the conclusion. Now, this should sound familiar because it's like a conditional statement. In fact, if we have, say, three premises, premise one and premise two and premise three, so if we take the and of them, because this is true only when they're all true, right? That implies the conclusion. So a valid argument um, corresponds to an implication in which the and of all the premises implies the conclusion. Now, if P1, P2, and P3 are true, then the argument is said to be sound. So, in other words, it could be that that these three premises do imply the conclusion, but they might not always be true. So it's only when they're all true that they imply the conclusion. Now, the way you use, the way you construct an argument, the steps um, that you use to show um, that these three premises imply this conclusion is a proof. So what we start with is we start with well, the question is this: how would we show that this is true? Because if we show that this argument is valid, to show this argument is valid, we need to show that these three premises imply the conclusion. So what we do is we say we're going to assume that the premises are true, and then have a sequence of propositions connected by logical patterns, by um, true statements that lead. So we have a proof will be like sort of like we'll have say proposition one, proposition two, proposition three. These are argument proposition one, argument proposition two, argument proposition three, argument proposition four, and then conclusion down here, where each one of these steps, why A1 is true, why A2 follows. So up here, we're assuming that the premises are all true. So they represent our starting point. We assume or suppose that they're true, because the only way that this could fail to be true, it could be failed to be a valid argument, is if all of these are true, but this was false. So we assume that these are true, and then we have a series of steps. Each one of these steps has to be uh, logically deduced from the previous ones we know are true. So it's these patterns here, these individual patterns that we're going to now study that allows us to make moves and proofs. Now, each of them is itself a valid argument, but it's a very small argument. So we've divided this up into small pieces. So these are the patterns of deduction that we're going to look at. And we're going to use them to construct arguments or proofs. So it's an application of logic, because each one of these patterns of deduction is going to be an implication. A P implies a Q. So we need to show that each of these patterns of deduction are true using truth tables or logical equivalences. Then we don't have to use the logical equivalences or truth tables, and we can just use the patterns of deduction, which are more like the kinds of patterns that are more congenial to the way that people think. So then we can sort of see how to go from that these propositions imply a given conclusion. Now, the context of this is usually math. So our context for this will usually be math statements. But to begin to understand how these patterns of deduction work. We're going to look at sort of everyday contexts without using math, so you can separate the math context, the math from what the patterns of deduction are. Okay, so let's begin to look. This is all in chapter 3. And here's the introductory material. And then what we're going to look at is these basic deductive patterns. Now, these patterns are explained in detail in the text, but they're also listed on this sheet, Inference 2004X. And what I've done, the reason I've called these, I've used the symbols X here to indicate that each pattern here, like here's a pattern of deduction here in which there's premises and a conclusion. Now I've used X and Y because they're like variables. So the idea here is that you can substitute for X and Y anything you want. And it turns out that if this first line is true and the second line is true, then then this pattern guarantees that Y is true. Now we're going to go through and do this in more detail with examples, but you might want to have this sheet handy so you begin to become familiar with the X and Y. Now I'm going to use P and Q because we think of P and Q as individual propositions, but they could be any complicated propositions we want. So when we apply this, then we might have to apply X and Y to like P and Q or P and Q and R or something like that. So they apply in a wider context than just individual propositions. So let's begin to look at them. There's 8 of them. There's 8 basic rules or patterns of deduction. Sometimes they're called rules of inference. Okay, sometimes I'll refer to them as sometimes logic is thought of as describing the way people think. That's not quite correct, but it is true that how people should think in terms of rules of it. In that context, you can think of these as rules of inference. And in fact, I think you'll find that you actually use these in an everyday sense all the time. So let's, let me just stop the recording here.